I'll be your moderator for today's webinar, Equipping Mobile Teams with APM Alerting. Before we begin, a few housekeeping items. We will be muting everyone and we'll be saving all questions for the end. Please submit your questions through the Q&A box on the bottom of your screen. And a recording of this webinar will be sent out at the conclusion of the webinar to all attendees. With that, I'd like to introduce our speakers for today, Bassam and Hashish, who'll be walking you through today's webinar. Hashish.
Perfect. Thanks a lot, Julie. Hello, everyone. So today we're going to be speaking about APM alerting and how to equip mobile teams with the APM alerting to aid them further in achieving the needed performance for their applications, mobile applications. So first, let's go through the agenda. We're going to have a quick overview of APM journal and how alerting falls under the umbrella of APM as a product. Which metrics can you get alerted for, and which APM metrics and their use cases. The generic use cases you can use APM alerting for to improve your mobile app performance. How can you receive those alerts, through which communication channels. We're going to have a very quick demo on how to create an APM alert from Instabug's dashboard. And then we're going to discuss the noise management, the infrastructure built by Instabug, and how you can tweak and customize your way further to reduce noise and make sure that you're being alerted for the exact issues you'd like to know beforehand. Then we're going to have a Q&A session at the end. So, first, Instabug's initial use cases were app stability and user feedback. However, the feedback we received from our customers through who have been making use of crash reporting and bug reporting was that they do not quite 100% reflect the actual perceived quality of the application. So, for example, what does a user mean by saying that the screen is slow or the application's performance is not satisfying? So that was the main drive when Instabug decided to build APM as a product, and the keyword was perceived quality. So mainly it helps the users to discover critical issues and balance between performance improvements and feature development, saving the team's time while resolving issues and aligning the team around a single metric to represent the application's quality. Alerting basically helps the users to proactively discover the critical issues and then have them prioritized, and hence or consequently it saves their time while resolving issues. So they just jump in the middle of the cycle instead of have to do the manual monitoring for each and every trace. Then you can just specify some alerts with the certain settings to have to be notified as early as possible when a certain issue occurs, and you just jump into debugging and resolving the issue. So which metrics can trigger an APM alert? So at the time being at Instabug, we offer Aptics as an APM alert trigger. But what is Aptics? Aptics is an application performance index, and it's an industry open standard for measuring applications performance. And it basically translates or reflects the overall app health and the performance of individual events or traces taking place or occurring on the application. So let's quickly discuss the reference of Aptics. An Aptics score of better than 0.94 is excellent. Between 0.85 and 0.94 is good. 0.7 to 0.85 is fair. 0.5 to 0.7 is poor, and beneath 0.5 is an unacceptable performance. But how is this linked to the APM metrics? So basically, there are certain thresholds on a trace level that you have to specify on the Instabug dashboard. For example, the time for screen loading and so. And according to these thresholds, they're taken into consideration to specify if an occurrence is satisfying, tolerable, or frustrating, which is then aggregated on an APM metric level to decide if, for example, the screen loading in general in your mobile application has an Aptics score of X, and so on. Then the occurrences taking place on a single session are aggregated together to categorize the session in one of four categories: tolerable, satisfying, or frustrating, and crashing if it ends with a crash. And the the pool of sessions is then aggregated together to translate or to reflect the overall app performance, which is going to reflect the overall app tech score of the application. The next metric you can get an alert triggered for is P95, and this basically reflects the experience 95% of the users are experiencing while using the app, or it also reads the other way around, which is you can also say that 5% of the users, or only 5% of the users of the application are facing a worse experience than the one denoted by the P95. So for example, if you have the screen loading of checkout page, if you have the P95 as 2.5 seconds, that means that 95% of the users are having the page loaded on their devices in less than 2.5 seconds, or 2.5 seconds exactly, but only 5% of the users have a slower experience, which is having the page loaded in more than 2.5 seconds. The third and last metric you can get an alert triggered for APM for at the current time by Instabug is the failure rate, and this basically reflects the percentage of failed network requests. So for example, if you have a network failure rate for the checkout API is 10%, that means that 10% of the network calls to the checkout API are failing. So now we're going to discuss the APM metrics and the related use cases, and Basim is going to help me with this. So the first APM metric is app launches. You can specify some conditions for the alert to make sure you're being alerted for the right thing that you'd like to receive. The first one would be app version. So you can specify certain app versions to get alerted for. And the second one is the launch type. So you can specify either to get alerted for cold app launches only or hot app launches only. And also the count of the sessions that you're going to specify as the sample size for the alert to operate on.
Yeah, so as your app keeps growing, your app launch time is expected to increase, right? So factors that affect the launch time include the device and OS the user is using, app-specific initialization logic, third-party SDKs, initialization time, and network latency. So most modern apps, they require fetching some sort of a remote configuration file, which obviously takes time, and it's important to keep those in check, right? So Instabug is actually able to capture the different stages that your app goes through while launching, and it will also capture those network calls that are actually taking place in parallel, and it's able to display them side by side, so that you know how much they're affecting your app launch time. So it's important to track any potential regressions in app launch time and to ensure that they're expected and to keep them in check.
Perfect. Thanks, Basim. So the next APM metric you can get alerted for is network traces, and the conditions you can specify for a network alert is the trace name, which is basically the URL or the endpoint that you'd like to get alerted for, and the HTTP method, post, get, put, or delete, and also the app version and the count.
Yeah, so network monitoring currently supports traditional HTTP calls as well as GraphQL and gRPC. And since Instabug is a client-side SDK, we're able to capture those hidden client-side errors that backend monitoring tools are not able to capture, right? So you can also define specific alerts for network calls that are made during the app launch, as we mentioned earlier. And you can also measure the failure rate as well. So it's not just about latency, you need to worry about how often they're failing and why they're failing, because this could also have a negative effect on the experience of your users. Another use case is monitoring third-party SDK network calls, which could indirectly affect the performance of your app's first-party network calls. And they could also be failing silently, so it's important to be able to monitor that as well.
Perfect. So the third APM metric you can get alerted for is custom execution traces, and the conditions you can set here is the trace name, and this is the name you give the execution trace while creating on your code, and the app version and the count.
So execution traces were introduced basically to cover those specific use cases that are unique to your app. And they also complement existing metrics that Instabug is able to monitor out of the box, right? So some of our users, they use execution traces in cases like a network protocol that isn't supported by Instabug, or anything basically that is a duration-based metric. So they can also complement existing metrics because they run in parallel with other traces. So you can have as many traces running in parallel as you'd like. So let's say a specific metric isn't showing you enough if you want a more granular breakdown of that specific metric, you can use execution traces in that case. You can have multiple ones running in sequence to basically have a better or more granular breakdown of that specific metric.
Great. So the last two metrics basically are on the UI part of things. So the first one is screen loading, and the conditions you can set here is the trace name, which is basically the screen's page name, and the app version and the count. And these are pretty much the same conditions you can also specify for a UI hang alert.
Yeah, so let me quickly define what a UI hang is. Basically, a UI hang is defined as a single frame taking more than 250 milliseconds, because this can be very frustrating for the user, because to them, this is perceived as that the application is not really responding, right? So this number is actually the standard defined by Apple. And it's important that you're able to capture those on production, because they're not necessarily easily reproducible in development environments or during the development phase.
Okay, so these were pretty much the APM metrics, all of them that we have recently discussed. And the next part would be the overall app. So basically, overall app aggregates or compiles together the performance of all the APM metrics, but also they take into account the crashing sessions as well, as we briefly discussed in the app export. So the conditions you can set for an overall app alert are app version and session count.
So with each new release, your app's overall performance and stability should be trending upwards, generally speaking. And this is why every app should have this configured, as it's especially useful for detecting regressions, right? Release over release. And it doesn't really care where the issue is. So even if a specific rule or the specific set of rules that you've defined, maybe they've failed to cover certain scenarios, this acts as more of a safety net, right? Because it does not care about which metric is causing the issue. It's more of a general health check for your application. So we recommend that you start with this and to tweak your targets accordingly.
Great, thanks a lot, Bassem. So the next part would be the generic use cases you can use APM alerting for, and the ones that are actually independent of any APM metric that can be set for each and every APM metric from the ones we discussed. And these would fall under three main umbrellas. That would be release monitoring, ownership monitoring, and regressions. So basically, as Bassem has mentioned in the previous slides, that you can use release monitoring alerts to specify through specifying specific app versions, and very soon we're going to be able to specify the latest app version as well, to be able to get alerted for the newest app version once it's live and adopted by the users. And you can also monitor the performance of critical traces, network APIs, screens, or execution traces on specific releases. And for the ownership part, you can specify the traces owned by you as a user or by your team, and specify them in the recipients. And this would come very handy if the development team is so huge, and you have squads only concerned, or where the scope falls under only certain parts of the application. So you can only specify alerts that will get you alerted as soon as an issue occurs when you're part of ownership. And the last part would be regressions. You can also use this to create alerts for the traces that you have received support tickets for, and you had them resolved to stay notified once the issue reoccurs, if it ever happens. Okay, so the next part would be the communication channels you can receive APM alerts for or on. So currently you can receive APM alerts through emails and Slack integrations. Very soon we're going to be launching an integration on Microsoft Teams, and consequently after we're going to have as well Ops Genie and PagerDuty added to our set of integrations. So here you can see a sample of the email alert that you're going to receive for an APM network alert. So basically you have the rule title or the alert title that you created with a link that takes you directly to the alert where you can edit the thresholds or the metric or the conditions or anything you'd like to edit in the alert. You have the platform that triggered the alert. In this example, it's an iOS application. The metric is a failure rate. The current value is 15%, which is greater than the threshold you set, which is a 10% in 1 hour duration. You also find the reason or the source of the alert, which is the trigger here, the network trace that triggered this alert, and the HTTP method, and all the conditions you set for the alert here. You also have a button here to take you to the dashboard to start debugging the issue from the issue details page on Instabug's dashboard. Pretty much the same data is being passed through the Slack integration, however, just in a different layout. But also you can use this button here to start debugging the issue on Instabug's dashboard once you receive a Slack alert. So now I'm going to show you quickly how to create an APM alert from Instabug's dashboard. So let me move to the dashboard. So here is the landing page of Instabug's dashboard. Once you sign in, you first have to go to the specific application that you would like to create an alert for. So for example, if you go to this application, you start by visiting the app overview page, but also you can continue the experience from pretty much any page on Instabug's dashboard, because here you have the alerts and rules page in the side nav bar. You can just click on it, and then you can click on the create button over here. You have to select the metric you would like to get alerted for. So you basically have the APM Metrics down there, and the overall app. You can also create for bugs and crashes. But let's, for example, take the network as an example. You then choose the trigger. Let's take an example of failure rate. You specify the threshold as, for example, 10%. And the time range, you have 4 of them: 1 hour, 3 hours, 1 day, and 7 days. So for example, let's say the 3 hours. And here you can add as much conditions as you'd like. The first one could be the app version, and you're going to select the app versions you would like to include. So for example, if you select those 3, that means you're going to get alerted if the issue happens on any of these 3 app versions. You can add more conditions, and the conditions are, of course, added together. The second one could be a trace name. So for example, if the trace name contains a checkout, for example, and you can add a method. So for example, you can include some of them or exclude some of them. So for example, let's specify a post input, and you can add a count over the sample size. So you can only get notified if the count is more than 100. I believe this is somehow generous, but yeah, anyways. So for the time being, you can forward to Slack, but in the next couple of days, you're going to have the email integration on production. So you can just select any Slack channel from the ones you already integrated, and you can combine as much actions as you would like. So for example, you can forward this to multiple Slack channels, or you can actually forward this to Slack and emails, or any other combination of integrations once we have the other ones created and pushed to production. And then you give the alert a name. So for example, it's demo network alert, and then you save here, and you have it here with summary shown on the alerts and rules page. So once you click once again on the alert, you are able to edit the triggers and the thresholds and the conditions and everything, actions as well. And once you finish your edits, you can save once again, or you can also, from this page, you can delete it. And here it's gone. Okay, so now we're going to discuss the noise management infrastructure built by Instabug. So basically, for rate limiting, an alert will only be fired once again, only if the performance has regressed after receiving the first alert. So for example, if you receive an alert for a certain trace, or that has been triggered by a certain alert, if the performance has regressed once again after the alert has been received, and then the performance has crossed the thresholds once again, you will receive a second alert. But if the performance keeps rising and never regresses, you will only receive the first alert and none more. The second thing is triggers and thresholds. They are aggregated on trace level. So this is an important thing that you must know, that if no trace name is specified in the alert configuration, they will be triggered if the threshold is crossed for one trace. And to reduce noise, you are advised to specify trace names so you can just get alerted for these traces only, not the complete pool of traces. The third one is the sample size. I'd like to tell you that the default sample size for the APM alerting is 100 occurrences. So, for example, if you specify a 5% failure rate and you have only 50 occurrences, even if all 50 of them are failing, you're not going to receive an alert unless you override the default counter by specifying a count condition in the alert. So to reduce noise, this has been built for 100 occurrences as sample size. Only if you override this, you're going to receive more or less alerts depending on the performance. So now how can you tweak or customize the alerts to further reduce noise even over the Instabug's infrastructure? So one thing you can manually do to reduce the noise from alerts is creating custom URL patterns. I'm going to show you in the next slide how to create it. But just to recap, Instabug automatically groups together network endpoints with similar URLs, but you can override this in the dashboard to account for any coupling of different or grouping of different network endpoints you'd like to do. And this, where applicable, can reduce much noise, because if Instabug is not able to capture the similarity between two URLs that you see that are very codependent or correlated, that you'd like to group them together. If you do not do this by hand, they're going to appear as two different traces on the dashboard, and they're going to qualify for sending separate alerts at the same time. But if they're grouped together in the settings by yourself, then they are going to appear on the dashboard as a single trace, and they're going to qualify for a single alert only if the performance crosses the thresholds you specify in the alert. And I'd like also to hint that very soon we're going to have trace name ORing launched, and this makes you able to specify more than a single trace name or more than a single trace name pattern in the alert while creating it in the configurations page. Here's how you can create a network URL pattern. So basically, from the side nav bar, you have the settings icon down there. Once you click it and you navigate to network performance URL patterns, you're able to create an URL pattern, and this takes higher precedence than the ones that are captured automatically by Instabug. The second way to do this, or to reduce the noise from alert from the APM alerts manually, is specifying key metrics and non-key metrics. This basically hits in the overall app aptics alerts. See, only the key metrics are the ones that are included in the aptics calculation for the overall app. So you just navigate to any list page from the Instabug's list pages for APM metrics, and you unmark the trace as a key metric by just clicking the star over there, and you will see it non-highlighted. Once this is done, then this trace is going to be dumped while calculating the overall app aptics, and no noise is going to be caused by this trace at all. The third thing you can do is to customize the trace target thresholds, and this is something I highly recommend. You can do this through the list page for most of our metrics by clicking on the target part over there. Once you click it, you're going to get this pop-up displayed, where you can specify the certain thresholds you'd like to specify for this specific trace. So it's logical that not all traces should have the same exact performance. For example, you know for sure that some network traces have higher payload than others, or some screens have more details than others. So logically they would have more time to load or so. So this helps you to make sure you are tracking or you're setting the right targets to track the trace itself and reduce the noise. This reduces the noise resulted from APM alerts by reflecting those thresholds here while calculating the APDIX score for a specific trace, which is then aggregated on a metric level and on the overall app level as well. Okay, I believe I'm done. If you have any questions, please feel free to ask me.
Awesome. Thank you, Hashish. We did have a couple of questions come in. What are the bare minimum set of alerts that you recommend each company should start with based on your experience?
Okay, so I believe the APM metrics are covering totally different parts or aspects of the mobile performance. So I pretty much recommend creating at least a single alert for each metric. I also recommend creating or overloading the metrics with different alerts. So, for example, the network P95 alert would reflect the network latency, but the network failure rate alert would reflect the failure rate itself. Also, as per the examples mentioned by Bassem earlier in the slides. So you can also track the app launch by an app launch alert, and also by a network alert covering the network traces that relate to the network calls happening at the app configuration at launch time. So I recommend at least 6 of them, 1 for each metric and 2 for network, 1 for P95 to reflect the latency, and 1 for failure rate to reflect the failure rate of the critical endpoints.
Awesome. Thanks, Ashish. Next question is, how do you know if the thresholds you're using isn't high, where to leave some alerts non-handled, and how to make sure you're covering everything?
Okay, so this part here is very tricky because the question you would ask yourself, which threshold that I can set for my alert to make sure I'm not being spammed with too much alerts, which are not reflecting critical issues, and which thresholds are going to actually reflect the critical issues without missing the opportunity to be to early detect issues early ahead. So one thing I recommend to do this is setting the target thresholds over here for each trace, and while knowing the actual performance of certain traces, this would give you a very clear understanding of the threshold that you're going to set if you're going to create an alert to track this specific trace. And also this can somehow relate to the targets you set for the application performance as a KPI for the application or for the squad or even on a company level.
Thank you, Hashish. Another question just came in. Can I eliminate third-party requests from being triggered in alerts?
Well, you can do so in 2 ways. First, by specifying them as non-key metrics, so the actual traces relating to third-party SDKs you are using are not aggregated in the overall APDIX score. However, this still imposes the state where you're going to receive, for example, a network alert for a trace which is a third-party trace that you would not like to track. So that's why I also highly recommend that you set trace names for your alerts, so you're able to reduce the noise and make sure that you're receiving alerts for the actual traces you'd like to be early notified once an issue occurs on.
Awesome. Next question is, when we configure alerts like failure rate of 10% in 3 hours, when are we notified? Is it at the end of 3 hours or as soon as we hit 10%?
Actually, it waits until the window is done, because, for example, if you hit if you hit an 11%, which is more than 10% in only the first hour of the window, that doesn't mean that at the end of the window, all the other requests that are going to take place in the next 2 hours are not going to regulate the figures somehow and make the overall number or the average less than 10%. So the complete time window should elapse before you receive an alert. If you'd like to get alerted for a duration which is less than 3 hours, you have the 1 hour window, and that's the least you have on Instabug at the moment.
Great. That's all the questions that we have. Thank you so much, Bassam and Hashish. Just a reminder that this webinar will be sent out, or recording of this webinar will be sent out later on this week. So thank you very much for joining, and hope everyone has a great day.
Thank you.
Thanks, everyone.
Thank you.
Thanks.